Hello and welcome to today's problem, 1838, frequency of the most frequent element. So the frequency of an element is the number of times it occurs in an array, and you're given an integer array nums and integer k. In one operation, you can choose the index of nums and then increment it by 1, and given this ability, you want to return the maximum possible frequency of an element after performing at most k operations. So one way we could do this is by having a sliding window. We first need to check to see what condition we need in order for something to be valid. So we'll go ahead and make a comment about that here. In order for something to be added as part of the final result, what we have to do is, you have to think a little bit. Okay. We can, okay, so let's say we have this example over here. 1, 4, 8, 13. What we can do is we can increment the right pointer forward for every single element in the array, right? So we move this forward to 4, move this forward to 8, etc., etc. Now, for basically this element in the sliding window, for the right pointer, what we can do is we can assume that the element that the right pointer is currently on is the number that we're trying to focus every other element to. So for example, we have this number 1 over here. We want to focus that and try to get it to equal 4. If we move this forward and it goes on to 8, we want to try to convert 4 into 8, etc. Like same thing with this. We want to convert 1 into 8 as well. So on and so forth. So basically, we need to figure out a way, like we need to figure out whether or not it's possible for you to be able to like convert those into the value 8. And we know that the integer k is pretty much your piggy bank of the numbers, the amount that you have that you're able to switch the numbers into. So knowing this, if we take a look here, we can figure out some sort of condition in order to determine whether or not a given amount is able to be converted, pretty much, or like whether or not this number is like the number that you should convert it into. So you can figure this out by having the following formula. What you can do is first you can take in the length of the sliding window, and you can multiply that with the elements at the given index. So we have nums I, in this case we have something like 8, and we can check to see whether or not this multiplication of those two is less than the total amount occurred, the total sum so far. So 1 plus 4 plus 8 plus k, so total so far plus k. So the reason why this works, if we take a look here, what are we doing with having this nums at the ith index along with the length of the sliding window? So what we're actually doing is we're doing like 8 plus 8 plus 8, right? Because the current length of this is 3. And if you think about that, that's basically the this is basically like the amount that we're trying to all aim for. We want all of these to equal 8. Now, we have to make sure that this amount is less than the total plus k, because you need to add a k amount. Like all you have in the piggy bank is k to be able to have it basically equal the like what we want it to be. So this condition, this is what we want it to be, and this is what we have so far. We have like 1 plus 4 plus 8. We have 8, 9, 10, 11, 12, 13. We need 3 more in order to have it equal the 8 plus 8 plus 8, which is like 24. Oh yeah, sorry, 8, 16, 24. I mean, we pretty much need like 24 minus like 8 plus 4, which is 12, 13. So 24 minus 13 amounts in order to see if like it's enough at that given point, right? And we know that we have k amount available in order to convert it from there. So that's why we do total plus k. So if this condition is true, then we do have the right amount in order for us to be able to like effectively use use this element as the correct one, and all the numbers from the left to the right one as part of the basically as part of the frequency. Yeah, as part of like the number, the amount that we can use to make it that amount. And basically, once this condition is true, we know that this is valid, and we can effectively like return that as the we can effectively turn that as a like possible result. So we have 8. This occurs 3 times. We can then return like that length as the final result. So another thing we need to do is we know that for like let's say like this 3, 9, and 6, in order for 9, like the elements in order to convert an element to 9, or like okay, let's see, like we want to convert an element to 6, right? In order to convert an element to 6, you're only allowed to increment the values up by 1. So in this case, the only values that we're allowed to increment up by 1 with is 3, because we could increment by 1 2 times, or like that could be a potential one, right? With 9, you're not able to do that because you can't like decrement it. So like that's something we also need to be aware of, and this is why we're going to sort the array beforehand, before actually basically running through our algorithm and checking for this condition. So yeah, that's something to be aware of, and this is why the time complexity of our solution is going to be O of n log n, because the sorting is n log n, whereas the actual sliding window itself is going to be O of n. So yeah. So if that makes sense, I'll go ahead and code up an example now. So we have pretty much from here, we want to have the left window, L equals, like left pointer, L equals 0. And then we want to have a right pointer that gradually traverses through the array, right? So we do for value in nums. For every single value nums, or let's say, actually we'll have like R in, let's say, length range nums. What we're going to want to do is we're going to want to see if nums I times the length of the sliding window, which is R minus L plus 1, is less 1 because it's the nature of a 0 indexed array. We want to see whether or not that's less than or equal to the total so far plus k. Now the total variable, we're going to want to keep incrementing that as we go along. So we'll have an accumulator over here, total equals 0, and then we can do total plus equals 1. We can then go ahead and do this if this is valid, pretty much. If this one is less than k, then we know that that value is a possibility, right? So if this is not possible, right? So if this is greater than k, then we know what we want to do is we want to increment it, right? We want to increment it until it is equal. So we want to like move the left pointer forward until it is a possible value. So in order to have that happen, what we can do is we can decrement that from the total. So total minus equals nums at the left, and then we do L minus equals 1. And then after this condition is pretty much fulfilled, after we know that it's less than or equal to the total of k, that's valid, what we can do is we can then set the like the max frequency. We can have a max frequency variable which is equal to 0. So we set it to 0 initially, and we can have the max frequency equal to the maximum of the total, or okay, so we want that to have the max frequency of either the itself, so max frequency, or the length of the sliding window, which is again R minus L plus 1. And then at the very end, what we can go ahead and do is we can return that max frequency value as the final answer. So if you go ahead and run this again, let's say with this array over here, okay, we'll go ahead and run it again. So we have the left pointer, starting off at this one here, and the right pointer starting off here. Both start at 0. We iterate through. We add 1 to the total. So total is equal to 1 plus. Oh, sorry, not equal to 1 plus equals 1. We want to add that with nums at the current element. So at the right pointer. At the right pointer, we add 1 to it, and then we go ahead and check to see whether or not the condition, whether or not these values is greater than the total plus k. If it is greater or equal to the total, if it is greater than the total plus k, then we know that the condition isn't valid. So we want to move that left pointer forward, and then increment that pointer, basically forward over there. So in this case, we have the total equals 1, and because the element of the current index, what is the element of the current index? It's 1, right? So 1 times the length of the sliding window, which is 1, so it's 1. Is that greater than the total so far plus k? Well, we can check to see what the total so far at that point is. It's 1 plus k is 5. It's not greater. So what we can do is we can set that as a potential for the max frequency. So max frequency equals 1. Yeah, because the sliding window length is 1. We can then move on forward to the next one. We'll go ahead and check to see what 4 is. Basically, we can check to see what the we can increment the total by that amount. So the total becomes 5 at this point. We check to see whether or not the 4, right? So 4 times the length of the sliding window, which is 2 at this point, right? Check to see whether or not 4 times 2, which is 8, right? 4 times 2, yeah, it's 8. Check to see whether or not that's greater than the total. The total so far, which is 4 plus 1, that's 5, plus k. K is equal to 5, so it's 10. So is this greater than the total? No. Well, no, it's not. So then this condition is skipped. We don't have to decrement that left pointer forward, and we can set that as a potential max frequency again. So max frequency at this point, total plus k. Yeah, well, the sliding window can be, at this point, it can be most frequently occurring can be 2. And then we can move on forward again, check again. We can see what 8 is, right? And then for the 8 value, if you set all the values to 8 so far, we'll go ahead and take a look here. Total plus equals nums are. So it's 1 plus 4 plus 8, that's 13, right? So total so far is 13. We go ahead and check to see what the current number is. It's 8. 8 times 3, 24. That's what we need in order to be able to switch 4 and 1 and 8, basically have them all equal 24. We check to see whether or not 24 is greater than the total, which is 13 plus k. 13, 14, 15, 16, 17, 18. It is greater, right? So at this point, it's actually not possible, right? We can't increment all of these values to equal 8, 1, 4, and 8, and to have that maximum frequency of 3. So this condition is actually fulfilled. We have to decrement the total amount. So the total, we negate 1 because it's subtracted minus equal nums at L. So this becomes, basically the total becomes 12. We move this forward, right? Because we do L plus equals 1. And then we check the max frequency. We begin the condition again. And then we see basically 4 and 8. Check to see whether or not that's valid. Yeah, we check whether or not to see whether it's valid, and then we have 4, 8. At this point, with 4, because the sliding window is 2 and the current one is 8, that's 16. Is 16 greater than the total so far? 8 plus 12 plus k, this becomes 17, right? So 12, because total so far is 12 plus 5 equals 17. That's greater than the 8 than 8 times the sliding window, which is 16. So that means basically this is ignored, and we can set the max frequency, and that's what we have our answer to, pretty much. So yeah, I hope that made sense. The time complexity is n log n, like I said before, and the space complexity is O of 1 because you're only storing just regular variables and not any elements of the nums array itself. Let me do just one quick look ahead through to see if there's any syntax errors. I see this colon that I'm missing over here. Other than that, if you go ahead and run this, oh, right. Oh, the whole thing actually needs to be indented. So if you go ahead and run this again, Oh shoot, sorry. Range length of nums. Go ahead and run this again. Oh right, so nums are. Let's go ahead and take a look at see if there's any more syntax errors. Total plus equals nums are. Nums are times r minus l plus 1 greater than total plus k. Right. We have a case here where the output is 2 when you expected 1. Oh, right. Like I said before, it actually needs to be sorted before. So we can go ahead and check for the greatest first because, like obviously, like you can't have like, you can't increment 9 to equal 6, stuff like that. So we have to do, basically sort. We want to have nums, equals sorted, and then nums. Go ahead and do that. Yep, all test cases accepted. Go ahead and run this. And we're accepted. So yeah, thank you for watching and hope this made sense to you guys.